Assalamu alaikum. In this section, we discuss about liquid chromatography. Now, in the previous section, we discussed about the chromatography and its classification. And now we discuss about liquid chromatography. What is liquid chromatography? Liquid chromatography in which the mobile phase is liquid. And now we categorize into other two parts: liquid chromatography and liquid solid chromatography. In liquid solid chromatography, in which the stationary phase is solid, we call liquid solid chromatography. And liquid chromatography, in which the stationary phase is liquid, we call liquid chromatography. Now, before going to the its categories, first we discuss about the liquid chromatography. Now, in a liquid chromatography, what is important? Its stationary phase nature and its mobile phase nature. Now, mostly our stationary phase is polar. Most of the time our stationary phase is polar, and mobile phase we use that is preferred is binary solvent or ternary solvent. That is a good for separation of the component, separation of the mixture from the mixture into its component. If our mobile phase is polar, it sweep over the absorb on the stationary phase, because our stationary phase is also polar. We repeat it again. If mobile phase is polar and stationary phase is also polar, now the mobile phase is absorbed on the stationary phase, and no space required for this absorption of the component that is absorbed on the stationary phase. Now that's why we use a binary solvent. What is a binary solvent? A combination of polar and non-polar. Why it is necessary? Because we don't know about what is the nature of our component or our mixture. Now the components are separate on the basis of their nature. Most of the time our stationary phase is polar. Now the polar component is absorbed on the stationary phase, and less polar component sweep through the stationary phase. Now we discuss like from this. For example, this is our stationary phase, and if we imagine that is a chromatographic jar in which the mobile phase is placed in it. Now our component is separate in this paper by different by this paper chromatography are based on the principle of the adsorption chromatography. Now this paper is polar and our component is separate on the basis of their nature. If our component is polar, it's polar, they adsorb on the stationary phase. If our component is less polar, then it's adsorbed on in this side, in the last of the paper, because it's show that it is less polar. Now it's the like dissolve like phenomena is applied on this method. If our component is stationary phase, is tightly bound to the stationary phase, that is polar. If our component is non-polar, is less tightly bound to the stationary phase. Okay, now there is that is important point that is mentioned in there, is that increasing polarity of the mobile phase will cause a greater absorption on the stationary phase, resulting in the decrease the number of adsorptive site available of the component. Now this point that we discussed now, if we increase the mobile phase polarity, that will greater absorption on the stationary phase, because our stationary phase is also polar, and resulting decreased number of adsorbent site available for the component. There is no space required for the separation of our component. Then next, this point is the component will then go into the mobile phase. In other words, the components are partitioned between the mobile phase and stationary phase in such a way that the concentration of the component in the mobile phase increase as the polarity of the mobile phase increase. Now there are two principles. First is absorptive and another is partition. In partition chromatography is the separation of the component depend on its polarity, on the concentration of its polarity that is separated. Okay, now we discuss about liquid solid chromatography, in which liquid mobile phase and solid stationary phase, and it's also called adsorption chromatography. Okay, in which we take a solid stationary phase and a solid form of stationary phase, that is fine granular smaller particles. Okay, what is the properties of the stationary phase? There are three properties that are mentioned in there, that is chemically inert to the mobile phase, chemically inert to the component of the mixture, and insoluble in the mobile phase. The three properties are required for the stationary phase that we use. Now it's called adsorption chromatography? Because its phenomena is same dissolve, same phenomena is applied on this. Now our stationary phase is polar. If our component is polar, that is tightly bound to the stationary phase. The rate at which the component of the mixture is traveled through the stationary phase is determined by the extent of its attraction with the stationary phase. So the liquid solid chromatography based on the adsorption of the stationary phase is also termed as adsorption chromatography, because it's adsorbed on the stationary phase because of the tightly bound to the stationary phase due to dissolve, polar, that is tightly bounded. Adsorption of the polar component on the stationary phase usually is caused by its attraction of the polar side of the stationary phase, and the generally increase as the polarity of the stationary phase increase. Now that is written is same like that I discuss now. Both are polar, and that is tightly bound to the stationary phase. It is therefore possible to control the retention time of a component by choosing the stationary phase of the property. Now, the retention time we determine. Now we know about what is the nature of the stationary phase and what is the nature of the mobile phase. But we don't know what is the nature of the mobile phase. We determine this by this technique. Now by the change the nature of the stationary phase, we control our retention time. If our component is polar and our stationary phase is also polar, our retention time is less. If our component is non-polar and our stationary phase is polar, now our retention time is increased. Now we use a stationary phase by decreasing the order of polarity: aluminum, silica gel, calcium carbonate, starch, and cellulose. Now there we discuss about the two stationary phase that is polar we use mostly. First is aluminium and other is silica. Now we use aluminium in several grades. What is the meaning of grades? Now we treat aluminium with water, and the water occupies space that is present in aluminium, so there is less space available for the absorption of component. That's why it's important we choose a different grades that are required for our techniques. Next is silica gel. We also use a silica gel that is a polymer of silicic acid, and both are the polar compound, and that have hydroxyl group that is important for tightly bonding to the polar component of the mixture. As a result, component of the higher polarity absorb more strongly on the higher polar component, and less polar component to be move faster. Now that is the same phenomenon. This is, for example, this is a paper, and this is a baseline there, and there is our component spots, and they absorb there. It means that is more polar because our stationary phase is also polar. If the component is localized, viscosized there, it means it is less polar. It's have faster time that is moved through there. And now next we discuss about the liquid chromatography. Now in liquid chromatography, we categorize into two more types, that is normal liquid chromatography and reverse phase chromatography. Okay, in chromatography we also use stationary phase is also liquid. Now liquid means the liquid we use in the stationary phase that is immiscible with the mobile phase liquid, and the liquid phase is supported on the solid support, which is usually polar in the case of the normal liquid chromatography, and in the reverse phase that is non-polar. We discuss again about normal liquid chromatography and reverse phase liquid chromatography. In normal liquid chromatography, our stationary phase is polar and our mobile phase is non-polar or least polar. But in the reverse, that is opposite to the normal. In reverse phase, our stationary phase is non-polar and mobile phase is polar. And non-polar, we use a coating of a star that is non-polar on the in the stationary phase. Now that is written there. A solid spot is non-polar substance such as starch, which is non-polar stationary phase such as cyclohexane is coated, and the mobile phase is usually is water. Next is its principle is partition chromatography, and we also call liquid chromatography is a partition chromatography. Its components are separated on the basis of their concentration of the mobile phase or stationary phase. These are separation. And in liquid chromatography there are two types of chromatography that are used, that is first is plane chromatography and column chromatography. We discuss in the next section, inshallah.